Okay, the class is getting recorded. Come on. Okay, this is lesson 6 of our C++ course. Last time we discussed about the solutions to the exercises. Then we learned how to read and write from and in files and parse the strings. We got familiar with regular expressions. We had some examples on that. We learned about classes, constructor, copy assignment, and destructor. And if you have seen the slides, when I uploaded them, I added one exercise to that. And I hope you have seen that and you have done it at home. We will, in this lesson, first I will talk about static variables and members. Then I give you the solution to the exercise that we just talked about. And I received some emails from you yesterday, I think 3 of you. And I thought that it's good to answer them in the class. Maybe that those questions are also your questions. And you have any question about the project, now you will have time now today to ask about that. After answering to your questions, we will go to the next topic, which is inheritance. We will talk about overriding, polymorphism, virtual functions, virtual destructor, inheritance specifiers, const functions, virtual inheritance. And if we find enough time, we will also talk about interface and abstract classes. If not, we will talk about them in the next lesson. So the first thing that we're going to discuss about are static variables and members. In this lesson, you will see more examples than just some theoretical text. I think it's better to learn them with these examples because you should see them in practice, not just theoretically. Although we had the course with the examples, but we also had some theoretical, some text next to that. But here, I will explain them through some examples for you. So if you need to write them, you can take note while I'm talking, but there is not much note on the slides, but you can see the examples. So the first thing is the static variables. The static variables keep their values and are not destroyed even after they go out of the scope. If you remember till now, we saw that if we have a regular variable, when they go out of the scope, we lose them because they are in the stack memory, and their nature is like that. And but we also had a heap memory. If we get some data from our heap memory, they will not be destroyed, but the pointer that is referring to those locations will be destroyed if it goes out of the scope. But with the static variables, they are really similar to regular variables. They are not pointers. They are not in heap memory. They are, again, in a stack memory. But the difference is that they will not be destroyed. So look at this one. You're familiar with the classes. Here we define a class. This is its name. It has 2 public members and 3 private members. This one is a constructor, and this one is a getter for this private member. And the definition of the constructor is written here, not here, because its body was not just one line. If it was just one line, I would write it in the declaration of the class, like here. because this one is just one line of code, I will write it here, not in the CPP file. So this will be written in my header file, and this will be written in my CPP file. And both of them, both of the files, both files has the same name as organ, but but they are not in a camel case format. They are in a snake case format, and you are familiar with that. They are not. For example, if it was the name of this one was my organ, the name of the files would be my underline organ. So and it's all the letters were in a small case. So, but what is, I mean, static variables can have different usages, but the usage that we are talking about here is with this example. In the constructor of this class, I define a static variable, and the difference is just it has one keyword before its definition. And I set that to 0. I initialize, I set MID to I. So MID would be 0, and I increment I here. When I create an instance of organ here, sorry, it will call this constructor, and its ID would be 0 because of this process that I just explained. But if we create another instance from organ with this comment, in the second time that when the constructor is called, this one will not be redefined. I mean, this I will not be redefined. It will keep, it will have its own, I mean, its previous value, which was 1. When we call this one, I became 1. And when we call this one, maybe when we call the constructor by defining another instance of this organ, MID would be 1, and I will be incremented again, will be 2. So now if I print get ID of or underline 2, it would be 1, and ID of 1 or 1 would be 0. So as you can see, the effect is that whenever I create another instance, it will have different ID. And it's not shared between different instances of the class, similar to other members that we have for this class. They are the member of the instances, not the member of the classes. They are not shared between different classes. Even if we have the same template for different instances, their data is different from each other. They are not shared between each other, I mean between different instances. This is also the case with MID here. It's not shared between OR1 and OR2. They have their own member. But this one is just a static variable inside this function. It's not a member of this class. We cannot access to I through OR1 and OR2 because it's just one variable inside one function of this class. But it will save its data for the next time that we will call that. Okay, what's the difference between static variable and static members? Here we had MID here just as a regular member. But here I added a static before that. When I do this, MID will be converted to a static member. I can set its value through the name of the class. And it's why I'm working with the name of the class now with this one. because MID is not a member of the instances of the class anymore. It's a member of the class. It is shared between all the instances. What does it mean? Okay, first I have the definition of this member here, and I set it to -1. When I create an instance of this class, this organ here, this constructor will be called. We do not have this one anymore here. This is another file, another example. So don't confuse these two with each other. MID now is, it was -1. We increment that, it would be 0. So for OR underline 1, it would be 0. And if we print this on here, it will give us 0. For the second time, when we call that, MID was 0, and now it will be incremented, it would be 1. But since MID is a static variable, and it means that it's a member of this class, and it means that it is shared between all the instances, when I print these two, both of them will have the same MID, and it will give me 1. For both, I mean, for the second time, when I call this constructor, it will call, MID will be updated. So it means that OR1 also referring to the same MID, and it also be 1. When we access to that, we are working with the same location of memory. The static member variables belong to the class rather than the objects of the class. So how can we access? Okay, here I said that for, okay, let's see, yeah. To get this MID, I define a public getter function to access MID. But as we just said, they are not an instance of the variables. A member of the instances. They are member of the classes. But if we want to access them through getID here, we know that this is a member of the instances, not a member of the class. Like MID here, all the things that we have here are not a member of the class, are a member of instances. So it means that we can't access them through the name of the class. We should get an instance of the class, and then we can access to these members. So what I'm doing here, I have a static member, which is a member of the class, but I'm accessing to that, having access to that through a member of the instances. What does it mean? To access a member of the class, I have to get an instance of that class and access to that, which is not correct, because it is not this MID is a member of the class. Why I should have an instance of that to have access to that? So what is the solution? How can we access private static member variable using public member functions like what we did here? So it needs to instantiate an object of the class type to use the function. Because of this function, we have to create an instance of the class. But what is the other option that we have? Is using static member functions. Okay, let's see what static member functions are. Like static member variables, static member functions are not attached to any particular object. They belong to the classes again. So, sorry. Here we have a class, and the first, instead of having just a regular gather here, we have a static member function, but it belongs to organ, not to an instance. We can access to them through the instance of the class, but it is shared with all the instances. So with this one, I'm returning this. And here, when I want to call this one, when I want to access to MIT, I just use name of the class, double colon, get cont, and now I can access. So I don't need to create an instance of organ to access to this static variable. When you have some non-static members like this two, it is not suggested to use static functions. So we use static functions only if we do not have any data members like this. Normally, they are equivalent to global functions and they are not recommended, but there are some use cases that they will come handy. So they will be handy for us. And we will see when they are really useful. So in this exercise, which I only gave you the title in the slides, I didn't talk about that in the previous lesson, but we're going to solve it now together. It also shows us when we can use static variables. Write a program which receives a list of people's characteristics, such as their ID, name, and age, and let the user edit their ages by entering an ID. The ages must be between 0 till 100. Give me your suggestions. Let me make it smaller. And now I think you can see. So the first question is that we should have a list of people characteristics, and people has some characteristics such as ID, name, and age. Tell me what is the container that you want to use for this one, the type of the container. No suggestion? No guess?
Maybe a map if the IDs are unique.
Yeah, we can go for that. Okay, and the other question is that we should let the user edit their ages by entering their ID, and the ages must be between 0 and 100. How can we handle that the ages must be between 0 and 100? What should we do? There are two things. When we have one constructor, inside that we should have the ages, and the ages should be between 0 and 100. And we also have a setter because we are going to edit the ages. And what should we do inside the constructor and inside the setter?
There should be some kind of an if loop of an if thing to check if the number is legal.
Okay, but if it was not legal, what should we do?
Maybe set an error.
How can you set the error?
Well, I will make an enumerated class with all types of errors and then have one variable that I change to wrong input data.
Yeah, but that's if you do it like this, you won't have any problem with the setter. But just imagine you will have a constructor. Inside the constructor, you will notice that the user entered a wrong age. But no matter if it is wrong or not, you will create that instance, because the constructor has been called. How can you notice that that instance is a valid object? Did you get what I said? Or you need, we are calling the constructor. The responsibility of the constructor, the task of constructors is to create an instance of that class. No matter what you are doing inside that constructor, it will create an instance. Yes, you will check if the ages is among that, you will set the age or you will not set the age. But how can you notice that the instance that is just created is a valid object? Because it will be created.
I don't know.
Maybe if so you have the wrong age, then you can immediately call the destructor.
No, it's not possible to call the destructor. Okay, one naive way is to have a member variable for your class. And when you see a problem, you can just set that, for example, the name of the variable is valid. And you will just set that is valid to false. And from the outside of the class, you can check if this instance is valid or not. Because you are saying when you are creating that, you will set it to false. And you know that there is a state in that object that shows you that this is wrong. This is not a valid object. But the problem with this is that you will create an instance of that class. You will have some invalid objects. Even if you know that they are not valid, but you will have them. Okay, what's the solution? To avoid the problems that we just discussed about, I'm giving you a solution that you haven't seen them before. But it's not the naive way, it's a better way. It's the best way that you can handle this problem. First of all, you are seeing now a complete example. Not 100%, but 90% a complete solution to that. So I think you also have such questions in your emails. The question was that, okay, where should I define this function? Where should I define these classes? So look at these slides. If those were also your questions, you can get the answer to your questions now. So I have a human ID. I'm defining an ID because I said that we have an ID of, our object has some IDs. Also, we have some error types. So we have two enum classes that we are going to use it probably in many different places in my project. Because of that, I put both of them in a header file whose name is data_types.h. This is the content of that data_types.h. If I want also to convert these error types to a message, to a clear message to user, I will also add a function to this data types.h. And inside that, we saw that example. How can we convert these error types to some clear messages to our user? You can go to previous slides and see the example. So you will also write that function inside data underline types.h. So we are going to use data underline types.h in other classes, other .h or .cpp file when we need them. So you see here inside, I'm declaring my human class. I have human.h. Okay, the name is wrong here. Let me correct this one. Oh. And as you can see inside the declaration of my the file, my header file, where I put the declaration of my class, I'm including that data underline types.h. Why they are between colon? Because they are some file in my projects. They are not coming from a standard template library, an external library. For external libraries, we use this notation. So whenever I need to use this one, not everywhere, whenever I really need this one, I will include them in that file. I need them, I had to include it here because I had to use error types, I had to use human ID in my .h file, in my header file. So look at the things that you are using here in your header file and then include them. If you are not using anything from that header file, don't include them. So how I can, from that example, I noticed that there are some humans with some characteristics. So it will tell me, it's saying to me that there is an object type and I can have that object by defining a human class. It's not similar to the past that we had just some container vector of vectors of vectors. I mean, we define something like that, but now we know that the number of properties of that object is more than 2 or 3 things. So in that case, we define a class. You can also go for a structs, but it's out of the scope of this course. The solution that we have here, we said that we have some invalid objects and we don't want to have those invalid objects. What can we do? And the problem came from the constructor. What can we do? We first make our constructor private. It means that no one can create an instance of human through the constructor. If they try, they will get error. But how we can let them create an instance of this human? We can create a static function, which we said that the static functions are part of, are a member of the class, not a member of the instance. It means that the user can access to this static function through the name of the class. They don't need to create an instance of that class to be able to see this static function. So we are creating a static function. As you can see, it has the same input as our constructor plus 1 error types, which you are already familiar. You just said that we should update that if we want to check a condition. If there is a potential error, we will add this one to handle the error. So from now, you can guess that create is going to call the constructor. Why? Because create is inside this class. It has access to all the private members. From outside of this class, we don't have access to the private members. But when we are in this class, we access to them. So let's first see this one, and then we will come back to this get ID and set age. Inside the constructor, we just set the MID, MName, and MAge, and we don't have any problem with them because we're going to have this one, the static function, which will check if the input data are correct or not, or input members are input arguments are correct or not. So here, the output of this create is std optional shared PTR of human, because we know that we set human are some classes, they are big data, like vectors or the rest, and we don't want to copy them when we are working with them. So that because of that, we create a shared PTR of that. It means that we have a pointer to them, and we share those pointers with other objects instead of working directly with those human objects. And inside these static functions, we are first setting error to no error. Then we are checking if name is empty, we set the error to wrong name. So it means that we have a problem. One of the arguments is wrong, and I'm setting the error to wrong name, which is clear to us it's a wrong input name. And I'm returning this empty thing, which is of type of std optional. Here, I'm checking if the age is between 0 or and 100. If it is not, I set to the error to wrong age, and I return an empty object. If there is not any error, we reach to this line. We reach this line. Then I will call and the constructor of my class, and since we are in this class, we can see the constructor, even if it is private member, because we are in this class. So I call the constructor, I get a memory location from the heap memory of this type, and return a shared PTR of that to the caller of this static function. So in the main function, first I set the error type to no error. I create a vector of shared PTR of humans, and then I will call the static function to get an instance of human. It will return an std optional object. We can check if it is empty or not. So if it is empty, it will return false. And I have to handle the error by showing a message to the user, or I think that for your first project, it would be just a message in your console application. But for your second project, it would be a message that will be shown in your GUI. And to do so, you need to write that function that will convert error types to some messages in your data underline types.h. If it is not empty, we have to access to that shared PTR human through this method of that std optional object, and push back that to our vector. As your friend said, we can have a std map of IDs and the shared PTR of human. So that would be also a good option. But again, it depends on your design and how you are going to work with that. But in this example, I only use vector because the main thing that we were going to discuss was not this. How about that getter and setter? So we have one getter for MID and one setter for age. Why I don't have a setter, for example, for ID, and why I don't have a getter for age? Because in this example, based on this scenario, I really didn't want to work with their ID. I mean, I didn't want to change the ID. First of all, it's ID. Probably we are not going to change that. If then it is a unique thing, it should be something that we are going to detect our object based on that. So first, we only create it once in the constructor, and we won't change it. So we don't let the user change that. As for the age, we said that we are only going to change that. So we are not going to have access to, we are not going to print it, for example, somewhere. So by this example, I wanted to let you, let you know again that you will only write getter and setter when you really need them. If you don't need them, don't do that. So this is the meaning of encapsulation. You only let your user access your data member or your function member of your class only if it is really necessary for the user to know about them. Otherwise, no, we don't share them. So for setter age, as your friend said, we for this setter, we will also have an error type, and we will handle it inside that. How? We set it to we set the error to error type no error again. We set that if it is not among between 0, it's not in the range between 0 and 100. We set the error to wrong age. Else, and as you see here, I don't update age. Okay, but because if I update the age with this one, then it would be a wrong, invalid human object. So I won't do that. I only set this to wrong age. But if it is not, if it is in the range, then I will update range. How can we work with them? For example, here I had a wrong age. If I come here, it will go to this because it will not create that for me. It will not create, it will return only an empty object as we saw here. It will return an empty optional object. How about this one? Everything is correct. Oh no, sorry. This is when we are going to work with the exercise asks us to let the user change the ID of, the age of one of the objects when the user enters their ID. So imagine we have here is stdcin, or someone else is calling our functions or our class, our data. So then we have an entered ID, and I use findef for human list, and I let this lambda function to see this entered ID, and I check for every item if their ID is entered ID or not. If it is, it will return a pointer to that item. And I'm checking if it is found, then I set the error type to no error, and then I will update that object, that ITR, with with the set age. And again, I should here handle the error. I didn't write the code here for you, but I think you can handle the error by yourself. So don't write like me. Okay, you will come to the demo day, and you will examine the day that you are presenting your work, and you will say, okay, you will write it like some comments here. But this is just because I don't want to spend much time in the class on these things. We had these examples before, so you know that you should handle this, the error here and also here. Okay. Before this, let's first of all, if you have any question now, you can ask. If not, we will go to your questions that you asked through your emails, and we will also again come back your question about the project. But did you get what this exercise and the static functions, variables, and members?
I have a question about what we included. So in the beginning, so let's say if you have, if you need to include string in your main and then in your human, and then also in another class, because I have something like that for my project.
Mm-hmm.
So I thought then, because I already include, let's say, human in my main, that I can only write include string in my human, and then it should also be included in my main. But what if I also need the string in another .h file? Then it will be included twice in my main.
Yeah, you're correct. But for those things, I mean, it's okay. I mean, I'm not that much strict about that and those. I mean, the fundamental data type in a standard template library. If you really need them, I mean, if you are as you said, for example, here I included a string here. And here, if I don't write this, I won't have any problem because human.h is included, and inside that you also have a string. But it's okay for these parts. I mean, for strings, for this fundamental data type, as long as you really need the strings here, it's okay. You can work with them. But if you don't need them, don't include them. Why you don't have any problem with that? Because here you wrote pragma once, so your string will be included only once. But I saw, for example, some people will come and I see in their project, there is a long list of include header files, and they are all copied from one header file and one CPP file to all of their CPP files. I won't like to see something like this, but if it is just one or two, it's okay.
Okay, thank you.
You're welcome. But did you get the static members and this exercise? If you have any question, you can ask. No? Okay, let's go to your questions. Oh. Come on. Okay, the first one was this. All of you apparently were working yesterday because all of you have sent these emails, have sent these emails yesterday. I have a few questions about the project. What should we return to the user, the file names or the contents of the file? As you know, you have some data in your files. You also have some data in your file names. Your user loads some data, and they write a query only on their file name. if they only have some query only on the file names, you know that you should know if this information is coming from the file name or it's coming from the file content. Okay, and when the user doesn't know anything about it's coming from the contents or if it's coming from its file name. But you, as the person who is creating this objects, should be aware of that. Okay, and if the user, for example, writes a query on the file names, for example, it's asking for a data that only exists in the file name, or it exists in the file name. So as long as it's the information that user is asking are included in the file names, you don't read the file content. You just work with the file with file names. So in that case, you only show the file names when you are showing the results to the user. You also only show the contents that you extracted, and you only extracted the content from file names because you didn't need the data from their contents. Okay, but show it in a very, not in a dirty way. Show, for example, with some columns, and every column belongs to one properties of your class, but not the file contents. But when the moment that your user have a query on the file contents, then you should, because the query is on the data in the file content, you have to extract them. So since you extract them, you can also show those data to the user. You don't have to store all of them, but you can show create a list of the results and show them to the user. And after showing them, you can destroy that list, because we're not going to have a query of the results of another query. We are going to, the project is not that much difficult. It's just working with the data that we loaded. We're not going to work with the results of those query as the input. So this is the answer to your first question. Ariana, are you here? Yeah, I can see you are here. Where should we put our function? What is the convention? Do we write them above the main or below the main and then use forward declaration, or is it better to put them in a okay, can you now answer this yourself?
So yes, for some functions we could put them in the .h file like we have seen for data types. Mm-hmm. And I guess if it's some really simple functions, then we can just write them in the main.cpp. Or do we write all of them in another file?
Yeah. You know, Ariana, I think you won't have many simple functions. You probably, the main thing, this is the answer, the whole answer to your project. You will have one object which is containing the whole information of the file. So you have some data package object, or you can name it anything that you want. It's something clear. And most of the functions are inside those things. I don't want to answer all of this because then there is no any question for you to solve. But I can give you this hint that you will have two different objects. One is for the data and one is for filtering your data. But that filtering will not have everything. Some of the tools that filtering is needed are existing in that data object. So you will have some function that helps that filtering object inside your data packages. So you won't have many functions that are really independent. Probably they belong to your filtering object, either to your filtering object or your data package object. But you will have, for example, one function similar, the function that will translate your error messages, error enum classes to some error messages, and as you said, we will put them in our data underline type. So it's not really good to have some functions in your main functions. I prefer not to see them. They should be, even if they are really independent, they don't belong to any class, they should be in a header file, and you should use forward declaration. Okay, are they clear to you, Ariana? Because we're going to go to another email.
Yes, thank you.
Okay, you're welcome. So this one. I was working on a C++ project and I had the following question about the desired function. Should the user give the input load cin, or is it also allowed to give the user first a possible command load select and then give him the options to choose one of the two by entering one? No. Afterward, you will be able to enter the path or conditions. Okay, I get what you are saying. No, it's not necessary, because you are going to process the commands. If the user entered, for example, print something, you should process that command as well and say that, okay, this is not a valid command. Your command is wrong. With the structure of the commands, you are aware of the structure of the commands, and you can process them, and you can let the user know if their if their command is wrong or not. So you don't give them any option. You can, if you want to be very have a good communication interaction with your user, you can give them some examples to know that this is the way that you can enter your commands. Give them some hints, similar to what I gave you in your project definition, but it's not necessary. What should be the output of the program? Should it for load incorrectly loaded? For this one, yes. For loading, you don't need to show me any data. You just say something like this: this path has been loaded correctly, and there are, for example, the total number of the files was this, the total number of objects are this. You can say it like this. Just give a summary of the data that you have loaded. But for this, for select, you should give me a list of, as I explained for the previous email, if it is if the query is on the properties of the that are included in the file name, you only give me the information that exists in the file names. And if it is from the inside of them, you should also give me those information. Probably only the information that I queried on that, not all of them. Are you here, Jelis? I'm not sure if I...
Yes, I'm here.
Okay. Is it clear? Did you get your answer?
Maybe the other question. So load should load the folder in which he will search for the required conditions or not.
I didn't get your question. Can you repeat?
So with the load command, we have to so if you put load c data, this data file is the is the folder, excuse me, where for the select command will be searched in or not. Yes.
Yeah,
okay.
Exactly. Yeah.
Okay.
We are not, as I said for the previous email, we are not going to have a query at the results of the other query. So we only have, all the selects, we work on the data that we have loaded with load command. But we may call the load command multiple times. Okay, if I call it for the second time, you should erase the previous ones and load the new ones.
Okay.
Okay.
Thank you.
So we are not going to make it much difficult to work the results of that. Even it makes sense, but we are not going to that. Even for the next project, we will not, I mean, next project that you are going to do, we are not going to do that. François, I'm not sure François is here, but we will answer his question. François, are you here? No, because he had the course last year. Okay, his question, I'm trying to implement regex in the project, but it doesn't seem to work with citizen inputs. Also, the regex website is showing me things that work there, but not in my code. Could we have, you know, last year I had many meetings with the students, and it was very time consuming for me. And because of that, if you remember, in the first lesson, Adrian said that your NASA is not responsible to debug your code, because last year I had to even debug people's code, and it gets. I mean, Adrian was not aware of that, and this was something that I did because I thought I should do that. But François is coming from the last year, and he didn't attend the lesson, and he thinks that I should do this one. Probably I will help him with his problem, but it's not something that I should do. So this is something private to him. I hope you don't have such a problem. If you have, you can ask me, and probably we can solve it during the class. Do you have any other question about your project?
Yeah, I just want to ask, so the in the explanation, it says that we only have to care about the text files, but in the data, half of it is images. So can we just neglect those?
Yeah, you just ignore them.
Okay.
Yeah. Because if you have any other question, you can ask. Don't hesitate to ask your question. You have, I think, 1 week, yes, to do your project. Okay. So apparently there is not any other question. We can go to inheritance. So from now on, whatever we are doing is not included in your first project. So, I mean, even the static things, you may need them, but I guess not. I guess you won't need them. I mean, it depends on you. Try to design your program such that you won't need them. You will need these things for sure. You will need the classes for sure, but probably you won't need these things because there is not any, you're going to with the prepared data. But if you design your program such that you will need them, so this is the last concept that you need to know about to do your project. So there is not anything that, I mean, from this slide onwards, you don't need anything. You don't know them. You don't need them for your first part of your project, but you will need them for your second part of your project. So here I have human class. You are familiar how to you know how to write a class. Here I have one constructor, and because I wanted to fit everything in this in one slide, I also put the definition of this one here, but it's not really common to have the definition with the declaration, okay? It's just because of these examples. I wanted to show all of them in one slide and to see all of them. It would be difficult for you to understand, but I'm going to explain if it was in some parts was in another file, in another slide, and some part in another slide. So it would be confusing to you. And because of that, I put all of them in the same file and the same slide. So don't think that you should also do that. So here we have our constructor, and we have also one getter for this member of the class, this private member of the class. We have destructor. We have public, protected, and private. Till now, we only work with public and private members. We didn't work with protected. I explained them to you in one of the lessons that we had. But the main usage of them, I mean, their usage is only when we have inheritance. Otherwise, they don't have any meaning. What's their meaning? Their meaning is that if I define a member, either a function member or a data member, as protected, it means that I can access to them either through when I am in this class, or in the inherited ones, in its children. So I can access to change name only when I am in human, or I am in employee or in teacher. Why? Because employee and teacher are children of human. But let's see, how can we have inheritance? Here I'm defining another class, employee. It's getting inherited from human in a format of public in the by this specifier. We will see the other way of having that, but the most common way is a common way of inheriting is this way, to have public inheritance. I have a constructor for employee, and here I get an instance of human because I am getting inheritance from human by calling the constructor of human here. And this is unlike what we do in Python. In Python, the inheritance is different. In Python, the inheritance, I mean, the classes are just some templates. They are not objects. I mean, it's more complicated than what I'm saying, but there you won't see something like this. So if you are familiar with Python, don't confuse them with each other. Here you have to create an instance of human because it's a parent of employee to be able to access to its members. But we don't have access to its private member. Privates can only be accessed when we are in this class. From outside of this class, through the name of the class, we can access to that. Through the name of the instance, we can access to them because they are private. Through their children, we can access to them. We can access to them only if we are in the human, because they are private to human. But for protected, we can access to them either when we are in human or when we are in its children. We have, for employee, we have also some private member. Human cannot access to them. Teacher cannot access to them. But only outside of the class we can access to them. But only if we are inside the employee we can access. We can have access to them, to the private members. Right. For get salary and set salary, they are public members for employee. So it means that if we have an instance of employee, we can have access to get salary and set salary because they are public. But we can have access to earn salary. Teacher is a grandchild of human, but it can, because it's inherited from employee. So indirectly, it's also inherited from human. But we only need to write an instance of employee to call the constructor of teacher here to, employee here, to call the constructs of employee to create an instance. Then the constructs of employee will be called, the constructor of human also will be called. So because of that, teacher can have access to the members of employee and the members of human, only the public and the protected ones. Here, teacher has one private member and also one getter for that private member. It has one public function here, which is calling the protected function of human. We said that protected members cannot be seen from outside of the class, but can be seen inside the children and inside the class. What are we doing? What is we doing here? What we are doing here is that we are calling this change name, which is a protected member, and creating a public function of that. We know that if we have an instance of teacher, we can access to change name because it's a public member. So it means that if we have three objects, one from human, one from employee, one from teacher, these two cannot access to change name. The instances cannot access to them because it's a protected member. And instances are not inside the class, they are outside of the class. We are calling the members through the instances, but we cannot call the protected members through the instances. We can only call public members through the instances. But here, for teacher, the instance of teacher can access to the public members of teacher. And that public member is calling the protected member because now here in this scope, we are inside teacher. We have access to it. So the instance of teacher can directly access to change name. You see, we have the same functionality, which is defined in the parents, but some of the children can, some of the instances of the children can see that, some others not. So these are the tools that you can play with that to implement your ideas. Sometimes you design your programs like this and you want to hide some functionality for some children, for some types of children, and for some others not. So these are your tools. Let's see what I explained just to you in practice. We have human, employee, and teacher, three different instances of these classes. When I try to call change name, since it is a protected member, I can't, it gives me an error. I can, from employee, can access to its public member, but again, I can access to this protected member. But with teacher, when I try to again access to this change name, which was a protected member of that, I can't. But if I try to access to change name, which was a public member of teacher, I can. And as you can see with my naming convention, I can understand that this is a public function, and so of course I can access to that. So even I don't need to go to its definition here to understand it. I can access to this one, or I mean, I cannot access to this one and I can access to this. Based on the naming convention that I use, I can easily understand if I can access them or not. So the other things, did you get this one? Did you get this? If we are going to go to another tools that you have with inheritance. Did you get what is happening here? Are you there, guys?
Yes, we get it.
Okay, very good. I think from time to time I wake you up. Okay. So the next topic that we are going to discuss about is overriding. You are familiar with overloading. They are very similar concepts. And if you go, for example, to an interview, a very simple question and common question that they will ask you is that they probably start with such a question that what is the difference between overriding and overloading? And by these examples, I will give you the difference and I will explain to you what's the difference between them. So overriding, we have again that human class, but we added one function to that, one public function, which is describe, and it only returns one string, string object, and it says that I'm a person. We write the same function in employee, which is inherited from human, with the same syntax, with the same name, same output, the same arguments. But the string that it will return is I am an employee, so that this string has been changed. When I here create two in different instances, one from human, one from employee, if I call for person.describe, it will call this one, I am a person. But if I call for employee.describe, it will call this one. Even if human has inherited from, employee has inherited from human, since we overrided this function, when we call describe, it we call this definition, not this one. So this is overriding. So unlike overloading, where the signature of the classes were different from each other, the name of the signature of the functions were different from each other. The name of, their name was the same. In overriding, everything is the same, only the body is different. The name is the same, the arguments are the same, the output are the same. And also overriding is between when we have inheritance. It's not, but overloading can be anywhere when we have two different functions, two or more different functions in the same scope. It doesn't have to be in one class. It can be also in one class, but with overriding, they are in two different classes which are inherited from each other. But with overloading, they are in the same scope. They are either in one class or just in one function without any class, for example, in a namespace. So, okay. With this one, I just said that for person.describe, it will call the describe of human. And for employee.describe, it will call the describe of employee. But what will happen with this one? This is an example of polymorphism. Based on Liskov substitution principle, which I didn't explain here, but I want you know that based on this principle, wherever a parent can go, the children can also go. It means that we should be able to replace the human with its children. So here I have a pointer which is referring to an address of type human. but its data is of type its children. Here it's employee. So we are getting a location of memory of type employee. New will give us the address of that location, and we are storing that address in a pointer of type human, of the type of its father. Now, if I use person1 and call describe, since person underline 1 is human, it will call the describe from human, no matter it is the data inside that is an employee. Now when we are calling when we are the user of this pointer, we don't know what is inside of that. As the user, we only know that it's just a human pointer. So because of that, it only calls the describe from human. This is not a bad behavior. This is a correct behavior, but you will use it depending on your usage, depending on your project, depending on the design of your project. Sometimes you may want something like this, but sometimes you may want, no, I want to have, for example, this thing, but I want to, by calling this, I want to call the method from employee, which is overridden in the employee. I want to call that one. If it is overridden, I want to call that one. In that case, you have to put virtual before the definition of describe in the parents. And it means that if this function is overridden in its children, and I have a pointer referring to human, a pointer of type human referring to a data of type its children, then call that overridden function from its children. Let's see here. These two, for the first one is I am person, for this one I am employee. For this one, since we put virtual here, it will call I am an employee. It means that it will call the overridden function from employee. For this one, we saw that since we didn't have that virtual keyword before the name of that describe in the human, we had I am a person because it was calling the function from human. So nothing has changed here. Nothing has changed in employee. The only change that we have was in human, and here this keyword. So again, both of the things that I said here, with virtual or without virtual, it depends on your usage. So it depends on what you are doing, how you are designing your program. Sometimes you may want this, or in some cases you may need the previous version. So these are the tools that you can design a good program. So here these are some examples of polymorphism. For human, we can have an instance of type human and store it in a pointer of type human. Again, employee, teacher, because they are the same. Human can have employee and also teacher, because employee is a children of that and is a child of that, and teacher is a grandchild of that. It could be more than that. So for example, we can have another class that is inherited from teacher, and human can also have a data of that type, content of that type, a location, a memory location of that type. I mean, we can have more levels in our inheritance. Employee can have of type a data, I mean, a memory location of type integer, sorry, of type teacher. But we can't do the other way around. We can't have employee with human data. So a child cannot have its parents, but the parent, based on this scope substitution, the parent can be replaced with its child. Person 2 is of humans, of type human, and we can't access to set salary, which is defined in employee as a public function. We know it's public function. You see this based on the naming convention. I know that. And if I also go to its definition here, you see that the set salary was defined as public. And we know that if we have an instance of employee, we can access to set salary. Okay. But here, person 2, although person 2 is an employee, but we are referring to that by a pointer of type of its parent, not a pointer of type employee. So from using this EMP, I can see set salary, but using person 2, I cannot see set salary. It's inaccessible. Again, in some cases, it might be our desired behavior, but in some cases, no, it might not be our desired behavior. If it is not, if we want to access to set salary using person 2, what should we do? The answer is that we should use dynamic cast. Okay. I have person 2. I want to convert it to employee, to a pointer of type employee, and store it to a pointer of type employee. If this conversion has been done correctly, it will return true. And I can now, from now on, emp2 is of type employee, so I can see describe, I can see this set salary, I can see get salary, both all of them are coming from the employee. If it is not converted correctly, for example, it was a pointer of another, I mean, if, for example, person 2 was a, for example, instead of writing person 2 here, I could write person, and the conversion will not be successful because it doesn't have employee, it includes human object. So in that case, it would return false, and we won't go inside this. How can we access? How can we use this thing? But let me just first this one. I explained this. Oh, yeah. I think I will explain this one. Oh no, it's a bit too late. Okay. So let me explain something to you here. And I think I need to write it somewhere. Okay. Imagine this is something that you will need in your second project. You have a library. I will make this example more in more detail later when I explain what is interfaces, what are abstract classes later on. But for the moment now, I think it's better to give you just a quick overview of that. You have a library here. probably you can see it. How can I? Oh. So all of them are title. How can I make it bigger? Or maybe I can use Word. Oh. So here we have, imagine we have one. We have one library here. We have two projects. Till now, you only had one project. We have one library here. Inside that, we have, for example, human class. And we have also iHuman, which is inherited from which, and what, let me public iHuman. Okay, so we have iHuman is an interface of human. Okay, and we have these two classes has been defined in my library. In yeah, we can say in our library we also have, okay, let me write it here. We also have a function. Okay, let's write this function get human, but it will return a pointer of iHuman. Okay. So these are all in my library. We also have, for example, receive human, which receives iHuman inside inside my library. So and I have a console application. I'm not sure if I rewrite it, the dictation is correct. I guess not, but console project. And inside that, we call this function from this library, and it will give us a human object. But I mean, it's just a pseudocode, so it's not exactly like this. But I want to let you know the concept behind that. But you will see the example in the next lesson. So with this one, I create an iHuman with this. But inside this, we're returning a new human. What we are doing here is that human is a class inherited from iHuman. And we said that our parents, iHuman is now a parent of human, and we said that our parent, we can have a pointer of type parent, but its data can be of type its child. So what I do here, this line is similar to write it's similar to what we are doing in this function is similar to write this. And we just saw that it's possible, we can do that, okay? But I'm doing that through this function, and I export this function to another project outside of my library, okay? Outside of my library here in console application, I only can see get human. I can't see human because it's not exported. I can only see iHuman, okay? So here, I can only work with iHuman. For example, for iHuman, you define some functions, and I can, as you just saw, I can only access to them since it's iHuman. And I cannot even do the dynamic cast to convert it to human because I don't see human here. I don't have access to human in my console project. But the only thing that I can see is iHuman, get human, and receive human, because you will see later on, we only export get human, iHuman, and receive human. We won't export human. We only export these three. Okay, we do some process, we work with some things, and now we are going to pass a human to our library again. So we are going to call receive human with this one, with a human. Now I'm passing an instance of type a pointer of type iHuman to receive human. Here in my library, I have access to human. I can see human because it's part of my library. What can I do to be able to process human? Because if I work with iHuman, I cannot access to the members of human anymore. What can I do? I can use dynamic cast here. As you saw, this again is just a pseudocode. I will have human star here, person, for example, equals to dynamic cast of type human star. Which one? My underlying human. Let me make it smaller. So now I have person of type human because I created that. No one could create iHuman in the console project. They only can create it through the function that I gave to them. And when I was giving this function, I created an instance of human. They don't know. In the console project, they don't know. They only work with iHuman, with the interface. Okay, but here in receive human, which is inside my library, I know that it's a person. It's a human. So I will convert that to human. I will have a person of type human, and now I can work with the members of human. I won't work with iHuman anymore. So while I am in the library, I work with human. While I'm in the console project, I work with iHuman. You will see later, but I wanted to explain what's the usage of dynamic cast an example of this usage. It's not the only usage of that, but I hope you get it. Just try with these exercises, try to implement them yourself to see how can you work with them. How they work. So For polymorphism here, what will happen if I delete person 2? Which kind of destructor will be called? Can you give me the answer? Oh, you can see the answer here. Okay, I hope you can see it now. Can you give me the answer for this? We are here creating a pointer of type human, but its data is of type employee. What will happen if we delete person 2, which is type human? Which constructor will be called? The constructor of human will be called, or the constructor of employee? Sorry, destructor of a person 2 will be called, or the destructor of employee? Any guess? You have two options. You can randomly say something. No one? No one wants to give any guess?
Maybe human.
Yeah, you're right. I hope you got that. You didn't get what I explained till here? If you don't get it, let me know. I mean, I just go and I ask, you see that I usually ask if you have any question or not. And if you don't ask any question, I won't notice that you didn't get. If you ask question, I can repeat that. I can give you more example. So human is of type, person 2 is of type human, as we just saw for this one. Yes, for describe, we saw that if we call this one, it will show us I am a person, because it will call the describe from human, because it sees only that. And if we want to call the member of the describe member from employee, we had to put virtual here. This is also the case for human, for the destructor. So we saw that for this one, we put virtual, and now when I call describe from person 1, it will call the describe from employee. Describe from employee was this one. At first, it didn't have this virtual. We put this virtual to be able to call describe from employee when it is of type employee. So tell me, how can we call the destructor from employee now? It's of type employee. I'm waiting for your reply.
If we put a virtual in front of the destructor in human?
Yeah, of course. Okay, make me happy, guys. Yeah, correct. You should put, and why we should do that? Because the data is of type employee. It means that all the constructor of this one has been called. Let me show you here. The constructor of employee has been called, and here, for example, we may have a vector of pointers, standard pointers, and which are filled by some memory location in heap memory. And if we call the destructor of this one, it will not delete them, because you remember from the previous lessons that we said that we usually delete our pointers in the destructor of the classes. So if I create a data of type employee, put it in human, and if I do not write virtual before the destructor of human, it will not call the destructor of employee. It will not delete all the information that is created by calling this destructor of employee. So because of that, we have to put, and it's very important, we have to put like this one, we have to put virtual before in front of the destructor of human. And it means that if there is if the destructor is overridden, call that one. And if there is an polymorphism, of course. So if the static type, this is the static type and this is the dynamic type. If the static type of the object to be deleted is different from its dynamic type, it means that we have polymorphism. The static type shall be a base class of the dynamic type of the object to be deleted, and the static type shall have a virtual destructor or the behavior is undefined. So do not forget virtual destructor when you have polymorphism. You will have it when you have interface in your project, and there you have your interfaces should have virtual destructor. And it's just like this. You only write the keyword virtual before that. Tell me what is the difference between overloading and overriding. I explained this to you just some minutes ago.
Overriding is when so you make an inherited class and then change a certain function which already existed in the other class. And then overloading is when you are in one how is it called, one scope,
Yeah.
and you make the function with one name but with different implementations for different data types.
Of course. Okay. I was really worried that you didn't reply for my previous question, but you're making me happy now by your reply. Okay, totally correct. As your friend said, with overloading, we have the same functionality, but with different bodies and different arguments, but with the same name, and in the same scope, 2 or more different functions. With overriding, again, we have 2 or more functions, but they are not in the same scope. They are when we have inheritance. Their arguments are the same, their name is the same, but their body is different from each other. And the last things that I want to say is that we have public inheritance, as we saw till here, that if we put like this one, let me show you first where it was. Oh, come on. We have only 2 minutes. It should not be broken now. Okay, it means that you are late. Okay, no problem. We will discuss about the next topics in the next lesson, because I know you will have other courses now. So if you have any question, you can ask. If not, we'll continue the next parts in the next lesson.
I have a question. In what form should we send you our projects? Just the files, or is there a special way to do it?
No, just send it to. It would be great if you send it with OneDrive, because all of us has an account with in OneDrive, and you can share it with via that.
Okay, so but I mean in Visual Studio, do we need to export the project or just CPP files and H files?
No, just the whole project in Visual Studio, just the whole folder that you have, the whole project.
Okay, thank you.
You're welcome. But the deadline is 22nd of, I think, 22nd of, yes. So the deadline would be the next lesson. It's okay till the end of 22nd. No question? Okay. you can now leave the class. Have a nice day, everybody. See you next week.
See you next week.
Bye. Okay, let me stop recording.